All right, so this one is on the chain rule 3.4. So chain rule, we're not really learning any, I guess, no new differentiation. Um, well, we might want to learn one formula towards the end. But it's really how do you differentiate composite functions, which can be a little bit tricky. So once you kind of get the basics of this down, so once we kind of do go through these first couple of examples that are a little bit simpler, um, when you get to the more complex examples, the really tricky part is making sure that you're following the process correctly because there could be a lot of moving parts to this. Um, so I think probably a good strategy would be to make sure you can do the simple examples and then move on to the more complex examples because as you'll see, the not only is the way that we're doing this um, that could be tricky, but there are also a lot of places to make mistake on the algebra part of this and simplifying the answer down to where it needs to be. Um, but basically the idea is if we want to take the derivative, so capital F of X is a composite function. And if we want to take the derivative, so we have F of G of X, we want to take the derivative, we take the derivative of F. So we get F prime of G of X, but then we have to multiply it by the input function there. Um, and then our other notation, dy over dx. If u is the input function, we'd have dy over du times du over dx. But I think more than kind of memorizing formulas, it's better to do several of these and kind of get used to the process. So if we think of this, capital F of X is square root of x squared plus 1 as a composite function, as say f of g of x, then our f of x would be square root of x, and our g of x would be x squared plus 1. Now, it's not necessary to write this part out. Maybe in the beginning, it's a good idea. So do it if it helps. If you don't feel like it helps, then don't do it. But basically, if we want to take the derivative of this with any square root function, probably write this as an exponent of 1/2 and then take the derivative using the power rule. So we're going to take the derivative. So treat this as one entity. So we have some function, we're raising it to the 1/2. So that would be 1/2. And then we're just leaving this part alone, just like if you take the derivative of x squared, you bring the 2 down, you don't change the x. You bring the exponent down as a coefficient, and then you subtract 1 from that exponent. So same thing here, but you don't, with x squared, change x. It doesn't become anything else. It's still x. Same thing here. The x squared plus 1 is not changing, but we are going to bring the exponent down, and then we're going to subtract 1 from the exponent. So 1 minus 1/2, or 1/2 minus 1 would be negative 1/2. Now, this is a part where kind of the new part comes in. We have to take the derivative of the input, the part right here. So the derivative of x squared plus 1 is 2x. So now it's just a matter of simplifying that. So the negative 1/2 exponent will be in the denominator with this 2, but actually 1/2 times 2, so those will cancel each other out. So we just have the x in the numerator and then x squared plus 1 to the 1/2 in the denominator. So we'll just go ahead and write that as square root of x squared plus 1. And then that is our derivative. Now, unfortunately, there's no way to really like when you solve an equation, you can get an answer and you can plug it back in to see if that works in the original equation. With derivatives, there's really no way to go back and check to see if we got the right answer. So just kind of have to make sure that you're being careful and know what you're doing. So the more you practice, the better you get it. All right, so another one. If we want to write our two functions that we're composing. The f of x would be x to the third, and then the g of x would be x squared plus e to the x. So let's take the derivative. So the derivative would be you would take f prime, but then plug this in to the x, and then take the derivative of that and multiply it. But I prefer not to use these, but if it helps, you can use those. So we're going to use a power rule on this one. So we have 3 times x squared plus e to the x, and we're going to subtract 1 from the exponent. And then we're going to take the derivative of this part in the parentheses. So that would be 2x plus e to the x. And we'll just leave that one. You could distribute the 3 to these two, but that doesn't really do too much, I don't think. So that's kind of the idea that we're working with. We'll start to get into some more complex functions as we go.